All right, here is part 2 of lesson 922. Again, our first day of doing constructions. In the first part, we saw how we could use intersecting circles to create a rhombus, and then go from that rhombus to seeing perpendicular bisectors, and then went from those perpendicular bisectors to actually an equilateral triangle at the way end. This time, we're going to kind of reverse engineer, work a little bit backwards. And start with a line, and then from a straight line we're going to try to create a perpendicular bisector really related to what we just did. Alright, so the first thing it wants us to do is, in our own words, describe the process, really describe our process from 975, or from the problem before. That is, given any line segment, how could you find its midpoint? Or, given any line segment, how could you find a line that's perpendicular to it? Alright, and this is going to be my explanation for that. So down in A, and I'm going to type it because I realized I should type sometimes. It's better than having to write out long things. But here's what I'll say. From the endpoints of the line segment, so like if you had a straight line from the endpoint to the other endpoint, you are going to use, so from the endpoints of the line segment, create two intersecting circles. That's what we did last time, right? They intersected each other, went through each other's center. All right? Then connect the intersection points. I should probably say then connect all the intersection points of the circles, of the two circles. That's what I'm going to go with. I don't really love that written explanation. Just because when you're talking about constructions, it makes so much more sense to see them than it does to write them. But it's a nice way of thinking, like, how can I make sense of this in a written way that makes sense to me? And that's, to me, the way that I can make sense of it. All right. So then in part B, it's going to say test my directions here from part A, what I just wrote, meaning I'm going to need a straight line, and then I'm going to see if I can make or create a midpoint, find that midpoint of that straight line using a perpendicular bisector. So I'm going to go to my Desmos, my ebook again, and I'm going to go, if you haven't already, open up that e-tool, and that e-tool then, it's going to be blank, but just create any line segment. Create any line segment, and I believe if I go to my resource page, it wants us to call it KM, and so I'll do that. I'm going to call this point here point K, I'll label it point K, and I'll label this one over here point M. All right, then my direction were to create two intersecting circles from these endpoints. So I'm going to go from one endpoint, create this circle. I think this is a little too big, and so I'm actually going to shrink this just a second and go to here, a little smaller. All right. From one endpoint, create a circle. From the other endpoint, create a circle, so that we get those two intersecting circles centered at the endpoints. That's probably a better way to write it, is instead of the way I have it written, where from to the endpoints of the line segment create two intersecting circles, I should really have it say that from the endpoints, or use the endpoints as a center, of the two intersecting circles. Okay, I like that a little bit more. Anyway, all right, and then the next part of my directions were to connect the points of intersection of these two circles. So I have an intersection point right here, I have an intersection point right here, and I want to connect those 2 points. All right, and that's going to create that perpendicular bisector that we were looking for. And that should be our midpoint right there in the middle. This point right here should be our midpoint. So if I bring up the problem, which is right here, it says test it. In other words, can you make this perpendicular bisector of KM and label that midpoint N? I believe I have. And we can even check that too. So I'm going to call that right here point N. I'll label that N. And then if I want to see if it's a midpoint, it should cut this in half. And so K to N, or KN, and NM should be the same length. And I can what I did there was I made a segment from K to N and from N to M so that those are separated segments. And then I can say that the length of that is 2.71, sorry, 2.17, and the length of the other one is 2.17 again. So that is bisected. That did get bisected. That means N is the midpoint, which is perfect. That's what I was hoping to see. Okay. Now it says return to your work from part B and construct a 45, 45, 90 triangle, and to prove that your triangle must be isosceles. Well, to be if it's a 45, 45, 90 triangle, that would have to be isosceles because the 45-degree angles would have to create equal side lengths. So what I'm going to do here actually is I'm going to use this angle right here, KN, and then down to this point because I already know that's 90. And then I'm just going to try to create a side length that's the same as 2.17. So I'm going to go from down to here, and let's see how long that really is. And we're going to kind of play with that a little bit. That's 1.9. I want that to be 2.17. See if I can get it. Struggling here to get to that perfect 2.17. Maybe I can change this one a little bit. I'm going to take a quick pause here until I can get it, and I'll start to further investigation here. I can't get it to be quite perfect. I can't really tell why, but after I looked into it, it's still going to work out for us. So if you can try to picture this as actually 2.18, it is the same length. I don't know why it's giving me so much trouble. But what I have here then is I have a 90-degree angle that I know because it's a perpendicular bisector. I have these two lengths that are isosceles, so hopefully that means that my angles here are 45, 45, and 90. So what I can do to check that is I can click this angle button, and then it says choose a point on a leg, choose a point on a vertex, and then the other leg to surround the angle you're looking for. So the first one I'm going to check is this really 90? And I'm going to click that leg, this vertex here at N, and then this leg right here, and yes, that is a 90-degree angle. Okay. Next is this K angle here, really 45, so I click this leg, this vertex, this angle, and yes, it's 45 degrees, which means my last one is going to be 45 degrees, but to check it, leg, vertex, leg, and I have another 45 right there. All right, and so I do actually I've constructed the 45, 45, 90 triangle, and I do see that it's isosceles. We just have to use our imagination a little bit. For some reason, I couldn't get it to be perfect. This is 2.18. This is really 2.18 as well. If it was off, it wouldn't give us this perfect triangle, so I don't know why it's lying to me. But that's how we would construct that. And it's a little unique because we didn't use the full length here. We actually had to just match our length 218, 218, and then use that angle button to see it's really 45, 45, 90. All right. Last one here in 9-77. So it says in problem 9-75, you use the facts that the diagonals of a rhombus are perpendicular bisectors of each other to develop a construction. In fact, most constructions are rooted in the properties of many of the geometric shapes you have studied so far. A rhombus can help you with another important construction. So they're going to have us examine here at the right this rhombus. And they're saying, well, what is the relationship between angle ABC and this line BD? I'm actually going to open up my tool for this one. And really, before I move on, what I'm going to do actually is, again, show you that snipping tool. I'm going to show you that snipping tool so I can put a picture of B and C onto my document here. And so you can see, again, how I want you to do it when you are putting it into your CAMI file. So I go to my snipping tool, it's already up. I click new snip. I take the whole picture, copy it, and then I can just paste it into my whatever I want. Okay, and that's my construction, and it's nice to see that I was able to make it. And for you, especially because this is your first time working on it, I do want you to post these pictures or put these pictures onto your CAMI so that I can see that you're able to make these and that you're giving it a good try here. All right, last problem, sorry, I get distracted on these. Okay, so the first, examine this shape ABCD. What is that relationship between angle ABC and BD? that angle is getting bisected. And so that line BD is an angle bisector. And so that's what I'm going to say down here for A. I'm going to just for some more room, and I'll put it in a text box here that that line BD is an angle bisector of angle ABC. Okay. And then, all right, so then the last part here, since the diagonals of a rhombus bisect the angles, use this relationship to construct an angle bisector of angle R on your resource page. That is, construct a rhombus so that R is one of the vertices, and use only a compass, a straight edge, and a pencil. And so the first thing, let's take a look at what that looks like. Oh, I'm going to delete what's on my Desmos here. Let's take a look at what that angle looks like. We'll try to create something similar to it. Doesn't have to be perfect. All right, that's what angle R looks like. It's just two rays starting at R going out. And so I'm going to try to create that here. Click array and create something that looks like this. It's close enough. It doesn't have to be perfect. We'll maybe make it a little bit bigger up here. Make it a little bit bigger. Yeah, something like that maybe. All right, and then this point right down here is that point R. All right, and then it wants me to create an angle bisector of that. All right, and here's how you create that angle bisector. And so what we're going to do is we're going to take a distance that's on that ray, and we're going to take another distance on the other ray and make sure that those are equal distances apart, and so that we have that relationship forming, that rhombus relationship forming. Oops, sorry. So I'm going to take a segment, extend it out to here, take another segment, extend it out to here, and we're going to see what those lengths are. So we can just kind of mess with that to make sure that they're exactly the same. That's 2.69. This is 2.65, pretty close actually. And then we'll make sure they match both 2.69 right there. Perfect. All right. The next thing I'm going to do is make my intersecting circles. All right. And because the intersecting circles, I know I can connect those connections and create that perpendicular bisector, and that perpendicular bisector should hopefully create an angle bisector here. Let's see. 2 points here. These 2 points here and here are going to be the center of my circle, and I'm going to do what I did last time. I'm going to create intersecting circles so that these centers are my center, and then I get this overlapping here and these intersection points here. All right. I'm then going to create a line that goes from R through my point of intersection here, and hopefully that does create an angle bisector. So if I put a line through here, all right, I'm going to see what that whole angle is. So I'm going to click on this ray, the R, and this ray, and that is a 61-degree angle. And so hopefully half of that is, hopefully we see that that's cut in half. And so I'm going to choose this point again, the R, and now this ray, and that's 30. Now, it really should be 30.5, but it doesn't do decimals here for me. But it really is 30.5. It is perfectly cut in half here. And I know that gets a little crowded in here. I don't know if I can try to space that out at all. And I'm kind of messing things up now that I'm moving things that I shouldn't be. But anyway, that was the idea there. Still using that idea of using these intersecting circles to create a line that bisects. I don't think, if I had to, the last thing I would do, but for time reasons I won't, I would take a snip of that picture of that intersection, that bisecting that I just made, and I would put it in there for B for Cami. And then that's the last problem. There is one more bonus problem on here. I would say give it a shot if you would like to practice this construction a little bit more, but it won't be on your actual lesson. But if you like to read the problem in the book and try it on the e-tool, please do so. It's a good practice problem. All right, that's all I got. If you have any questions about constructions, please email them to me.